So in this one, let's ask an interesting question, that is how to get or solve derivatives using an alternative approach, taking limits such that we have a central reference point. The exact wording of this question, let's see what it gives us. Might be interesting. Let it work. Yeah, symmetric limit. Okay, usually we have derivatives to the right side. We have a point, take a limit slightly to the right. So let's see what happens when what we can do. So the standard definition would look like this, the first one, and the central symmetric one would be slightly different. So we approach some point A, let's say, okay, we go h to the right and h to the left. So we have an example, let's check that out. So if we have our example to be x squared as a function of x, then it could look like this, and let's see how it expands. Interesting. So they do give us expression of a, so we see it works out for x squared. Let's ask it. Important note, let's see what it tells us. The symmetric limit only works if the derivative exists. There are rare cases where the symmetric limit exists, but the actual derivative does not. Okay, interesting insight. We could verify to what extent that is the case. So that's nice, and we can either, for example, look at when it fails or how it connects to Taylor. I actually want to solve a harder derivative in this way. Some harder derivative. Let's see what it does. Let's push this method a bit further with a harder example. All right. Okay, x cubed. I mean, it's not that much harder, theoretically, but it's a harder it's a odd function. Okay, so let's see what happens. A lot of manipulations. Does it work out then as a limit? It actually does work out. So, okay, non-polynomial. How would it deal with that? Maybe do Taylor or something. Let's see. Okay. Oh, it shows its strength here. Okay, it says. Oh, wow. So we use some identities. Okay, interesting. So what derivative are we taking? Sine x. So we want 2 cosine a sine h. Okay. Wow. So sine h over h. Yeah, that's a well-known limit. So we use a known limit. And it does get there. So that's really interesting. Okay. Well, I'm not gonna take it longer than this, but I think it was a very interesting thing to see. Here they just make some notes to the end. Symmetry eliminates the cosine terms automatically. That's nice. You're left with a clean factor involving sine h over h. That's nice as well. And it avoids messy expansions, it says, so that's interesting. Oh, they even give us e to the x. Connects to hyperbolic sine. Oh, algebra is trickier, okay. Well, I'm not gonna ask it now to do the algebra, but let's just call this enough for now. I think it's been interesting.